Okay, in this video, I will show you guys how to come up with the reduction formula for the integral of sine to the nth power of x, and where n is just a positive whole number, bigger than or equal to 2. So that means 2, 3, 4, 5, and so on. And as you can see, if you want to integrate this guy, well, the purpose of reduction formula is we want to have a lower power. And of course, I don't want to integrate sine to the nth power. We know how to integrate sine to the first power, don't we? Yes, we do. And then why don't we just integrate that and then differentiate the rest and then put them together? Yes, we'll be using integration by parts. So let's take a look right here. I will put this down as the integral, and let me just put this down right here. This right here is the same as saying sine to the n minus 1 power of x, and then times sine to the first power of x dx, like this. And when we do that, we can use integration by parts. And of course, I will show you guys with the di setup. Yeah, traditionally, this is just labeled as the u, and this is the dv. The same thing. And then right here, don't forget to put a plus minus on the side to get ready. And I will integrate sine x, and I will differentiate this, which is sine to the n minus 1 power of x. All right, integrating sine x, we end up with negative cosine x. Good. And then when we differentiate this guy, don't forget to put the power to the front first and then minus 1 to the power. So we first have a parentheses with n minus 1. That's the original power. And then the sign stays. N minus 1 becomes n minus 2 of x. And don't forget the chain rule. We have to multiply by the derivative of sin x, which is a positive cosine. This right here is the derivative of sin x. This right here was the integral of sin x. So be sure you know this really, really well. And I will just write it down better for you guys. All right, now we are going to construct our answer. Remember, when we multiply diagonally, that's the first part of the answer. So I will put this times that, which I will write down the negative first. And I'll write this down, the original, which is sine to the n minus 1 power of x, and then cosine x right here. That's the first part of the answer. How nice is that? And then don't forget, when we multiply a row, this right here is still an integral. So as you can see, negative times negative, that's positive. So let's put on plus. And this right here is just a constant multiple. So I can actually write down on the outside. So I will write it as n minus 1, and then I will put the rest in the integral. And check this out. We have sine to the n minus 2 power of x, and then we have cosine times cosine, which is, of course, cosine square of x, like this. And again, negative times negative, we took care of that already. That was a positive right here. So this right here is pretty much it after we have done the integration by parts. And in fact, we can simplify more because we see that this right here, cosine square x, we can write this as 1 minus sine square x. And then we can just look at this integral and then break it into two integrals, and something's going to work out really nicely. You will see. First, I will just distribute this inside. And perhaps let me just write this part down for you guys. I'll do this in blue. First, we have the n minus 1 all the way in the front. And then the rest, I will do this one in blue. I have this integral, right? The first part is this times that. So we have the integral sine to the n minus 2 power of x times 1. That's it. So I'll close this right here. Secondly, I have this times that. And as you can see, sine to the n minus 2 times sine to the second. When you add the powers, n minus 2 plus 2 is just n. That's very nice. This is a minus, I'll keep it. And then we have the integral. And again, we end up with sine to the nth power x dx, like that, which is very, very nice. And as you can see, originally, this right here is precisely the integral of sine to the nth power of x dx. And then we know that we have the first part of the answer right here, which is this. So I'll write it down as negative sine to the n minus 1 of x times cosine of x. That's just the first part of the answer. And then as of this part, don't forget this was a plus. I will just distribute. So the first part is n minus 1 times the integral right here, integral of sine to the n minus 2 power of x dx. And then this times that, which is a minus, thanks to this minus. And then we have the n minus 1 times the integral of sine to the nth power of x dx. Yes, this right here, it's also a repeating situation. So I will just go ahead and add this guy on both sides so that I can get rid of them. I'll come here and then I will write this down as plus. We need to add n minus 1 times the integral sine to the nth power x dx, like this. Very nice. All right, here we go. Let's see. This right here is technically a 1. And then this and that, what you can think about is you can factor this out. And you just do 1 plus n minus 1. 1 minus 1 is 0. So all in all, the coefficient is just n. So I will just put down n times the integral sine to the nth power of x dx. And then we have this right here. So I'll write it down. This is equal to negative sine to the n minus 1 power of x times cosine of x. And then we add this right here, which is n minus 1 times the integral sine to the n minus 2 of x dx. Are we done? No, because we have this n right here that's bothering us. So don't worry, it's an easy fix. Let's go ahead, divide everybody by n. Of course, it's like this by n. Very nice. Cancel this out. So finally, ladies and gentlemen, we have the integral of sine to the nth power of x dx, and this is equal to, perhaps let me write the 1 over n all the way in the front. So we have minus 1 over n, and then we have this sine to the n minus 1 power of x times cosine of x, and then I'll put this down right here first, which is plus n minus 1 over n times the integral of sine to the n minus 2 power of x dx. So as you can see, originally this integral has sine to the nth power, and we end up this function. This is the answer part, and this integral, it's an easier version because it's the n minus 2 power. So this is the reduction formula for that, which is very nice. I'll box this. Right? And perhaps some of you guys can make a video on showing us how we can integrate sine to the second power and also sine to the fourth power of x by using this formula here. I'll be looking forward to watch your videos.